Howdy folks, Mr. Koffler here with a lesson on the trends of the periodic table. We already talked about organization, what the different chemical classifications are, metal, nonmetal, metalloid. We talked about the two names for how things are ordered in the periodic table, what a group is, what a period is, and how things vary across a group and a period in the periodic table. Today I'm going to introduce four topics, four other trends of the periodic table. So, first of all, the first one is atomic radius. Atomic radius of an element is the distance between the nucleus of the atom and the outermost part of the electron where it meets the next atom when bonding. That's the atomic radius. So, which of these elements over here have the largest radius? The answer is iodine. It's the largest atom, so it would have the largest radius. Now, look at this table of data. On the bottom we have atomic number. On the y-axis we have atomic radius. So, here are the elements in group 8, the noble gases, the far right. Here are the elements in group 1, the alkali metals that are on the far left. So, what do we see going on? What is the general trend as we change within a group? So as we go from lithium to sodium to potassium down group 1, what do we see happening? We see it increasing. As you go down a group, atomic radius increases. As atomic number increases in a group, the charge on the nucleus increases and draws electrons closer. The number of energy levels increases and it shields electrons from the attraction of the protons in the nucleus, and the shielding effect is greater than the effect on the increase of the nuclear charge. So, all in all, atomic radius increases from top to bottom within a group. Okay, that's a group, that's up and down. Let's talk about left to right across a period. So, this is group 1. Remember, this is group 1 on the far left, and this is group 8 on the far right. Remember, it's group 1 on the far left to group 8 on the far right. So what do you see happening? What is the trend that occurs from left to right? You should say that as you go from left to right, atomic radius decreases. So, as atomic number increases across a period, each element has one more proton and one more electron than the preceding element. Electrons are added to the same principal energy level, shielding the effect. The shielding effect is constant for all elements in a period. The increasing nuclear charge pulls the electron in the highest occupied energy level closer to nucleus. So, all in all, that means the atomic radius decreases across a period. As you move left to right, atomic radius decreases. Here's just a quick summary. Notice I had to fix this. As you go top to bottom, things decrease. Or sorry, as you go top to bottom, things increase. I'll draw a triangle like that. It's increasing from top to bottom. And as you go left to right, things decrease. Increases top to bottom and decreases left to right. So, what has a larger radius, the halogen or the alkali metal? Remember, this is alkali metal, this is halogen. Your answer should be alkali metal. Alkali metal has the largest radius because things on the right are smaller than things on the left. Next topic, ionization energy. Ionization energy is the energy required to pull an electron off an atom. Here is some data on ionization energies. So, what do we see going on? In general, it decreases from top to bottom within a group. In general, it decreases from top to bottom with the group. Notice, the top of group 8 is helium and it goes down to xenon. The top of group 1 is lithium and it goes down to cesium. So it decreases from top to bottom. So as atomic number and atomic radius increases within a group, means as you go down, less energy is required to remove the electron from an energy level. Next, let's talk about it across the period. So looking at this data once again, how does ionization energy vary from left to right across the period? Remember, right here is group 8 on the far right, and on the bottom we have group 1 on the far left. So what do you see going on? Group 1 on the far left, and as we increase and go to the far right in group 8, what happens? You should say it increases, meaning it takes more energy to remove an electron from things on the right side of the table. It takes more energy. The trend is it increases left to right across the period. Here's a summary of ionization energy. It decreases top to bottom. So I'll draw my triangle like that. It's decreasing top to bottom, but it increases left to right. So next up we're talking about ionic radius, the radius of the ionic form of an element. Now before we get into that, you have to remember metal atoms tend to lose electrons to become positive. Cations are positive ions, so metal atoms become cations, and they are always smaller than the atoms from which they form. On the other hand, nonmetal atoms tend to gain electrons to become negative. A negative ion, or a nonmetal that has gained an electron, is called an anion, and they're always larger than the atom from which they are formed. So look at this question right here. Is sodium larger or smaller than the sodium ion? Based on this information, sodium is larger. Cations are always smaller. So, look at the pictures right here. Each of these is a metal, and each of them has lost an electron. Each of them has become a cation. And notice, every time they are smaller, lithium goes from big to small, sodium big to small, potassium big to small. So, when an atom loses an electron, the attraction between the remaining electrons in the nucleus is increased. It's sort of like this. If you are carrying 2 apples, you have a tight grip on them. But if you're carrying 4 apples, you have less than a tight grip. So once somebody comes along and takes an apple, you can tighten your grip a little because it's a lot easier to hold 3 than 4. Same thing with electrons. When it loses the electron, it can have a tighter grip on the electrons that are remaining. Now once again, here's the opposite. All of these are nonmetals, and all of them are gaining electrons to become anions. As the number of electrons increases, so once again with the apple analogy, if we add an apple to your number of apples you're carrying, it becomes harder to carry the more apples you add. You have a looser and looser grip on it. Same thing with electrons. The more electrons you add to an element, the harder it is for the nucleus to get a grip on it. And the trends in ionic radius kind of follow the same with atomic radius. It increases in general top to bottom, and it decreases left to right. Last term, electronegativity. Electronegativity is the ability of an atom to attract an electron, to attract it. So a high electronegativity means it has an easy time attracting electrons, while a low one means it doesn't gain them very easily. Do not mix this up with ionization energy. Remember, a high ionization energy means it takes a lot to remove an electron, while a low ionization energy means it takes a very little. So here are some electronegativities in general. Notice cesium in the bottom left corner of the periodic table has the lowest, and fluorine in the top right has the highest. So in general, it increases in a diagonal. The bottom left has the lowest, and the top right has the highest. Here is a summary of everything we just talked about. I would take a moment to pause this screen. And remember, in class, I handed out a periodic table pattern worksheet that is due for the notebook check on Thursday, the 20th, same day as the exam. If you lost it, and need another one, you can find it in the classwork homework test link. Have a nice day, folks. I'll see you in class.